we're going to take that. All right. So we've got, oh, this is over here now. What's going on? How do I do that? Does it look like it worked? Whatever. I'm done. No, I quit. All right. We're going to do some more bounded area problems, okay? Find the area bounded by these two functions, okay? Sketch graph. You guys know what the graph of x to the fourth looks like? Very good. It looks like x squared, but it's much more narrow. It doesn't look like a w till we add a bunch of other stuff there. So, this is just the parent function. Yes, it looks very similar to a parabola, which has already been stated. I cannot give you credit for that. All right. So that's y equals x to the fourth. And then we've got y equals 2x squared minus 1. What does that look like? Parabola up, shifted down 1 unit. Who knows, right? Well, does it intersect? Are you sure? What's that? Very good. It would appear like this would definitely be a scenario where you say it's going to be wider, but there's a 2 in front. So that draws it in. Okay. Yep. But who knows? We don't really know if they intersect until we identify the intersection point. So what does look like the top function in this scenario? X to the fourth, and the bottom function? 2x squared minus 1. So we know how to subtract and set up the integral, but first we need to find the bounds. In order to find the bounds, we have to find their point of intersection. How do I find their points of intersection? They're both equal to y, so I set them equal to each other. Is x to the fourth equal to 2x squared minus 1? Let's see. What do I do to both sides? Good. X to the fourth minus 2x squared plus 1 is equal to 0. Does that factor? Yeah. X squared minus 1 times x squared minus 1 equals 0. Do those factor? Yep. X minus 1 times x plus 1 times x minus 1 times x plus 1 equals 0. So I have a double root at -1 and a double root at +1. Okay, horrible graph the way I drew it, but you get the idea, right? Thank you, Carol. So, we've got that. Now, there's some interesting pieces to this. So we have our integral, but I want to show you a shortcut. Very important shortcut. As you think about these graphs right here, since we now know that they do in fact intersect, since we do know that they intersect, I'll try to draw them just a little bit better. Basically, we got one that looks like that, and one that looks like that, say. Something like that, right? I actually think they touch tangent is what happens. I haven't confirmed that, but I believe that's what happens. Do you guys agree that it's symmetrical on the left side as well as the right? So watch this trick. You can set this up as the integral from -1 to 0, or I'm sorry, -1 to 1. Top function, which is x to the fourth, minus the bottom function, which would be -2x squared plus 1 dx. Or you could slice it in half. If I slice it in half, it would be from 0 to 1 of x to the fourth minus 2x squared plus 1 dx, and you double it. So if you notice that symmetry takes place, I would rather plug in 0 as opposed to plug in -1. Would you guys agree? So, you know, this is just going to double the value of the integral, which will give us both sides. If you see that symmetry, go ahead and take that shortcut. It's a nice way to work around it. So, what is the antiderivative of x to the 4th? X to the 5th over 5 minus 2x cubed over 3 plus x, evaluated 1 to 0, and we will double that result. My common denominator will be 15, right? So I have 3/15 minus 10/15 plus 15/15, and we'll double that result. So 3 minus 10 is -7, plus 15 is 8, doubled, and you get You guys got it? Can you guys see? Was I in the way? You okay? Hope you feel better. Hey, everybody okay with that? Little trick of the trade. All right, let's do next one. These are all new problems. I'm really worried about how they're going to work out. So I haven't worked all these problems out yet. So I'm sorry. So we'll see. I'm kind of nervous. All right. What does y equals x to the 3rd minus 3x squared plus 2x look like? Yeah, woo-woo. Very good. So if I want to graph it, I think the easiest way is if I can find the x-intercepts. And this does factor to, we can factor out an x, right? So if I factor out an x times x squared minus 3x plus 2, does that factor? X times x minus 2. God, I'm struggling today. All right, x minus 2 times x minus 1. So you can see that this graph, it's a cubic and has x-intercepts at 0, positive 2, and at -1. So I'm just going to plot those. Yes. I was very frazzled. I lost my lunch. I found it now. Okay. Yes. Okay, what does the next one look like? Okay. Well, that's the graph. So I got two integrals. Is it possible that these are the same area? It is possible. I don't know for sure. It's hard to tell whether or not the shape is symmetrical. So we really do need to set up two separate integrals. I do not know the bounds at this time. How would I find the bounds? Set them equal to each other. So I've got 2x minus 2 equals x to the 3rd minus 3x squared plus 2x. What to do, what to do? Put them all on one side. The 2x's go away. I've got 0 is equal to x to the third minus 3x squared plus 2. Oh boy. Complete the square only works if you got square. This is a cube. So really good idea, but it is voodoo math. I don't think so. Let me show you. If you have a cubic and it does not factor, you have to use something else. What's it called? Rational roots theorem. Right? Guys, come on. Hey, we got it. Guys, come on. Look at this. Let's be mathematicians for a second. How many places does this intersect? 3. What's one of them that you know? You know 1. Look, if you plug in 1, what do you get? 0. So we can reduce this down to a smaller polynomial by simply plugging in 1. Synthetic division. When I find out who your pre-calculus teacher was next year, or last year, I'm going to have words with him because he obviously taught you nothing. All right, here we go. So we set it up. We just reduce it to find the other factors. So here's what we learned. 1 is a root. If 1 is a root, then x minus 1 is a factor. And you end up with x squared minus 2x minus 2. Does that factor? If it doesn't factor, what do you have to use? The quadratic formula. Take out your calculator. Give me the results from the quadratic formula. Yeah, what do you got? That's what you got? Super. It came out? Oh, okay. All right, very good. So, shh. Look at your bounds of integration, everybody. We've got those shapes, okay? And this one right here, you can see negative 0.73. This is going to be positive 1, and this is going to be 2.73. Okay, so we have our bounds of integration. How do you know they're symmetrical? Yeah, it sure looks, if they have the same distance between the intersection points and this spot is in the middle, sure looks like they would, in fact, be symmetrical. Yep. Instead of dealing with the symmetry part, let's just verify both ways, and we'll see that it does, in fact, double. So, let's set it up. My first integral will go from negative 0.73 to 1. Okay? And if I go, there's a lot of room on the backside if you need to jump over. And then what's the top function? We're gonna deal with this one right here. Okay? So x to the third minus 3x squared plus 2x, and we have to subtract off of that 2x, and it'll be a plus 2 dx. So let's go ahead and figure out this antiderivative. The 2x's go away, so x to the third over x to the fourth over 4 minus x to the third plus 2x, evaluated at 1 and negative 0.73. So this is the point where I turn to my calculator, because I'm going to have to use a calculator for negative 0.73 anyway, and I just go into y equals, and this way I'm going to get some values. Say 0.25 x to the fourth. So when I go into my table, I can then just type in these values to see what this gives me, right? So, because watch, we're going to make it real quick the second time. You're going to see how it works out. So when I have this, I just type in my values of 1. I get 1.25 minus, I plug in negative 0.73. I get negative 1. So I get 2.25. Now, watch what happens with the next integral. When we set it up, we are going to go from 1 to what? 2.73. What's the top function? 2x minus 2, and then you're going to subtract x to the third plus 3x squared minus 2x dx. So look at what you end up with. The 2x's cancel, right? And you end up with a negative x to the third plus 3x squared minus 2. How does that compare to your previous one? It's the same function, it's just negative. Well, no, it'll area between two curves will always come out positive. Yes, this is negative, but when we plug in these values, we'll still get positive results. So as we work through this, you end up with negative x to the fourth over 4 plus x to the third minus 2x evaluated at 2.73 and 1. So on my calculator, all I have to do is when I go into my y equals, I can just, insert a negative and a parenthesis to make the whole thing negative. Because I'm just dealing with the negative integral, right? It's the exact same thing. So I just save some time. I go into my table, and I type in 1. I get a negative 1.25 minus, just I ate a bowl of stupid for breakfast today. Okay. So we get 1 minus, and we already figured out we're going to be negative 1.25. And we got 2.25. So you can see we get positive areas. So Emma suggested that they were symmetrical. Are they symmetrical? Sure looks that way. Add them together, 4.5. So that's kind of like problem number 4 on your worksheet from yesterday. Only, here's the difference. Problem 4, the two slices are not symmetrical. If you view them graphically, you can see that there are, in fact, 3 intersection points, and you have to split it up into 2 slices, 2 pieces, and they are not symmetrical. So, got to be careful. Yeah, so now I'll ask example here. What do you notice is different about this one? Yeah, look at this. X equals y squared minus y. Now, I know your pre-calculus teacher taught you this last year. What kind of shape is that? Oh, it's not a circle. It's not a oval. What is that? That's a parabola. So what's that? It's a sideways parabola. That's all it is. Just go sideways. Parabola. Alright, so I figured out instead of the x-intercepts, now I figure out the y-intercepts. So we got 0 and we got 1. If it's positive, does it go to the right or the left? It goes to the right. So we can graph this. This is no big deal. Okay. Okay, so this is a parabola that goes to the right. Its intercepts are 0 and 1. So if I draw this shape, I get something that looks like... Everybody okay with that? And then I've got y equals 2x minus 1. What does that look like? It's a line. Shifted down 1. Okay. Here's the trick, everybody. This is so key to you moving forward. When I integrate this, okay, when we were, you know, if I draw vertical rectangles, watch what happens, okay? Vertical rectangle, right? Because we draw an infinite number of rectangles. If I take the top function minus the bottom function, what happens? What do you notice about the top function and the bottom function? It's the same. So we can't do top function minus bottom function. We can't have we can't draw our rectangles vertically. Instead, we got to draw them. Oh yeah, look at this. Oh. So this is what we're doing. We're going to find the area of all of these rectangles. We're going to draw them that way. So now my top function is the function to the right. My bottom function is the function to the left. And instead of integrating with respect to x, dx, I integrate with respect to y, dy. Very good. So, let's lay this out so we understand. We have a top and we have a bottom, okay? Or we have a right and we have a left. What is our function to the right? The line, y equals 2x minus 1. What is the function to the left? X equals y squared minus y. Now, if you're integrating with respect to y, okay, therefore I need to change this so the variable I'm working with is y. So see how this one's written as an x equals? This one also needs to be written as a x equals. So let's do that. Y plus 1 is equal to 2x. Now I divide both sides by. So 1/2 y plus 1/2 is equal to x. So now I have my left function and I have my right function. I have them both. Do I know where they intersect? No. If I am, before we used to look from left to right for our bounds. But now we're looking we're looking for this y value right here, and we're looking for that y value right there. Well, I have an x equals and an x equals. I can solve for y by setting them equal to each other. So we have y squared minus y is equal to 1/2 y plus 1/2. Does anybody else hate the fractions? Very good. We're going to take Megan's advice. We're going to multiply through by 2. 2y squared minus 2y equals y plus 1. Now I don't have fractions anymore. I would like to solve, so set it equal to 0. So we have 2y squared minus 3y minus 1 equals 0. AC method. Okay, let's just factor it then. 2y and y. What happened? It should. What? Okay, we'll use the ugly numbers. When I copied down the problem, maybe it was supposed to be a -2 or something. There's something I messed up there. So the problem I did last year factored. I remember it full well. This one does not factor. If it did, great, you'd be good to go. It doesn't factor, so you end up with, as Emma said, 1.78 and -0.28. So we had to use a quadratic formula. Like I said, the problem I did last year factored. I don't know what happened. I blame track and field season. So. All right. All right. So let's integrate. We have the integral. What's the lower bound? -0.28. So we move from bottom up as we look at this, and we got 1.78. Now we take the left function minus the right function. What's the left function? Right function minus left function, so we've got 1/2 y plus 1/2 minus y squared plus y dy. Yes. I won't count points off. I'll do it just because I got them taken off one time. So. Nope, I won't do that. So here we go. We've got a negative y squared. 1/2 y and positive y makes 1/2 y and positive 1y makes 3/2 y. And then I've got 1/2 and dy. So let's take the antiderivative. What's the antiderivative of negative y squared? And 3/2 y. Or 3/4 y squared. When you divide by that 2, it becomes divided by 4. And what's the antiderivative of 1/2? 1/2 y. We're going to have to use our calculator anyway because we've got an SD decimal. So let's go ahead and got -0.333. And I know you can't grab a y. That's okay. Just plug in as x and you can get the same thing. Plus 0.75 x squared plus 0.5x. And then if we go to our table, 1.78 is -0.73 or 1.39 minus, then I do -0.28, -0.07, apparently that's the area. So, how about you just work on that assignment I gave you yesterday, that worksheet. Tomorrow, we have a full workday in class on area problems from your book. How's that? Do you want them right now? Okay. So give me tomorrow at the beginning of class, okay? Yep, sure. Okay, so there's the assignment you'll do tomorrow in class, full workday. Make sure we get it. Nice way to end a Friday, wouldn't you say? So Elizabeth is gone. Should we give a shout out to Elizabeth? You know she's going to watch video. She's in like, where is she anyway? Robotics convention. My robot can beat up your robot. Is that kind of how it... All right. Okay. Elizabeth, we hope you're doing great. We really missed you today. Have a good day.